We're now going to do a titration. A titration is a process that a chemist uses to determine the concentration of a solution. And the reason we do that is sometimes when you would think that if we weigh out a substance and find out how many moles of that and putting in our volumetric, we would know exactly the concentration. Some compounds are very hygroscopic and they'll absorb moisture from the air. For example, sodium hydroxide is very hygroscopic. When we take a sample out of a closed container, it's a nice solid tablet. But when we put it on the balance and wait a few minutes, it's going to absorb moisture from the air and thereby changing the mass. So our mass is not going to be a true mass. So in the cases like that, what we have to do is we have to take a known concentration. In this case, we know the concentration of the hydrochloric acid because we can measure it exactly. And we're going to use that to standardize the solution that I made. Now I think I measured out what I thought was a 1.0 molar solution. So what we're going to do is decide, is that 0.9 or 1.01, and get this to 3 significant figures and get the exact concentration of our sodium hydroxide. To do that, we're going to use a burette. This is a burette. You can see that it's calibrated. This burette holds 50 milliliters. This stopcock is a Teflon-coated stopcock that has a hole through the middle. So if it's parallel with the glass, it's open. If it's perpendicular, it's closed. If I want to do just a small drop-wise, I can turn the knob here. Okay? So I'm going to close this, and I'm going to put our sodium hydroxide that we want to standardize in the burette. So I'm going to pour this just a little bit above the 0 mark. But since I'm not sure how clean my burette is, I'm going to rinse that burette with a little bit of the sodium hydroxide just to make sure that if there was any acid in here before, I'll neutralize it, and then I'll just waste it. So this way I make sure that my burette is clean and has excess sodium hydroxide, if anything, in here. Okay, so I'm going to close it at this point, and then I'm going to refill it. What you'll notice is that it's closed here so that there's air in this part right here. So when I put it in back in our burette stand, I'm going to take my waste beaker and put here and make sure this is filled with solution. And then I'm going to look at the top, and I'm going to use a burette reading card. It's just a card with a piece of tape on it that gives me a reference so that when I look at this, I can see exactly the volume. You can see I'm above 0, so now I'm going to let it out a little. So it's on the 0 mark. This is my waste container, so I'll set that aside. In my Erlenmeyer flask, I'm going to use the hydrochloric acid that's standardized. Okay? And to get exactly 25 milliliters, this is very much like our volumetric flask. It's been calibrated to exactly 25 milliliters. This is 4 significant figures, 25.00. So we're going to fill it to that mark right there. What I'm going to do is pull it a little bit more than I need. So I'm getting higher than the mark, and then I'm going to let it out slightly. So I'm right at the meniscus. I'm going to take this out, and then I'm going to take off the bulb and just let gravity work. Now these are factory calibrated. So when you let the solution out of a volumetric pipette, there will be a little drop left on the end. You don't want to worry about that because the calibration includes just the amount that leaves the pipette. Okay, so we'll wipe off that drop. Now we have our 25 milliliters of hydrochloric acid in our Erlenmeyer. Now, since we're using 2 clear solutions, we need to have something that will tell us when we have reached the end point. So I'm using phenolphthalein. And in an acid solution, phenolphthalein is clear. But in a basic solution, phenolphthalein is going to turn pink. So what we know is that we know exactly how much hydrochloric acid we have, and we're going to add exactly that same molar concentration, and when it turns pink, we'll know we've gone 1 drop too far. Okay, so I'm going to adjust this so that the drops are going to go definitely into my Erlenmeyer, and they're not going to splash out. I'm setting this whole thing on a stirring hot plate, so I have a magnetic stir bar that's going to help me keep everything stirred. And now we're going to gradually add. You see that pink color that comes right away? And then it disappears. So we can keep adding as long as that pink color is there. And since I know that we have a 1 molar solution and we had 25 milliliters, I know it's going to take about 25 milliliters of my sodium hydroxide. Can you see that pink color? But it goes away very quickly. When it begins to stay, then we're going to slow down the rate at which we're dropping. You see, we're almost there, so I'm going to just try to do drop-wise. If I think I'm almost there and I want to just add a half a drop, I can take water and just rinse off that end, and that last drop will fall on this. I think we have reached our end point. So at this point, what we know is we have equal moles of the sodium hydroxide and the hydrochloric acid. So we want to read our volume. Our volume is 21.5 milliliters. Okay? So now you do the calculations.